Boys and girls, Mr. McGeen here. It's Saturday morning and I'm hanging out playing on the Geo board and I'm thinking, what am I thinking? Come on, tell me, what am I thinking? What am I thinking about, Joseph? That's right, I'm thinking math. And I've got a couple rectangles drawn here on the Geo board. You know how to do rectangles on the Geo board, but I just wanted to kind of do a quick review here. I'm looking at this rectangle and I'm kind of considering the perimeter here, wondering exactly what is the perimeter of this rectangle. In other words, what is the distance around the outside of this figure? When I calculate when I calculate the perimeter, remember that we are measuring the distance between the pegs. So I saw a number of people in last week's work where they were counting the pegs to find the perimeter. So they were saying that this perimeter would be 1, 2 pegs, 3 pegs, 4 pegs, 5 pegs, and so on. Be careful, because when we use the geoboard, we're actually counting the distance or the units between each of the pegs. So we have a distance here of 1 unit from that peg to that peg, and from here to here would be 2 units, and then 3 units, and then from here to here would be 4 units. Sorry about the drawing with the pen here. I'm not an expert moving this pen around on the pad here. So from going down this width here, we'd say from this peg to this peg would be another unit. So now I'm up to 5 units, 6 units. From here to here would be 7 and 8 units. Notice how I'm counting the units between the pegs. This would be 9 units. Ooh, that's an ugly 9. 10 units. And be careful, from here to here would be 11, the 11th unit, and finally from here to here, 12 units. So we'd say the distance around this figure or this rectangle would be a perimeter of 12 units. We don't know what those units are. Could be centimeters, could be meters, could be kilometers. Remember, this is just a picture, a representation of something that we might see in real life. Now, looking at this, something that might be 4 centimeters long and 2 centimeters wide. Can you think of anything that you might have laying around the house or you might know of that would be about 4 centimeters long and about 2 centimeters wide? I'm not really sure if I can think. What was that, Peyton? Your eraser? Well, that's a good answer, Peyton. Thank you. Yeah, your eraser might be about 4 centimeters long and 2 centimeters wide. That's a good answer. I'm not sure if you can think of anything else, though, can you? Well, I'm not sure. What's that? Oh, excellent suggestion, Karsten. Yeah, Karsten, you've been playing some dominoes at home, maybe in your downtime. That could be about the size of a domino. Now, if those units weren't centimeters and they were meters, and we're talking about 4 meters long by 2 meters wide, that's a little bit bigger. That might be, oh, I don't know, maybe the size of your bathroom. Maybe one of your small bathrooms would be about 4 meters long and 2 meters wide. Maybe ask mom or dad, they could help you out with that to tell you about how big your bathroom is. But you can see changing the units really changes the size of the item that we're talking about. There's a big difference between an eraser and a bathroom. Just changing the units changes the size considerably. Now, when we're doing perimeter, do we have to count all the way around the outside edge? Is there a quicker way of doing that? Well, I know I noticed that some of you, when you were doing your work last week, were kind of taking that, not a shortcut, but you're using your knowledge of geometry to come up with another way of measuring perimeter. So you would count 1, 2, 3, 4 units. So you know that top side is 4 units long. And you know that the opposite sides of a rectangle are the same length. So that would mean that this side of the rectangle would be 4 units long. Now, what about the width here? Because remember, we're talking about length and width when we're talking about two-dimensional shapes like rectangles. So here we have 2 units. And again, opposite sides are equal in length. So we would have 2 units on each side. Now, easy peasy adding. Use my doubles. 4 plus 4 is 8. 2 plus 2 is 4. 8 plus 4 is 10. Or I'm sorry, is 12. So we would have 12 unit perimeter for this rectangle. Now here's a question for you. Are these rectangles different? No, of course not. You're right, Macy. They're exactly the same. They are what we call congruent. They're the same size and shape. Even if I took this rectangle and turned it on its side or rotated it in some way, they would still be exactly the same rectangle. We would call them the same or congruent, which leads me to my next question. Taking a look at this rectangle, is this rectangle congruent with that rectangle? In other words, are they the same size and shape? And of course, the easy answer is no, they're not. But what about the perimeter? Are the perimeters the same or are they different? Well, let's check it out. Let's count them together. We have a width of 1 unit, so opposite sides would mean that that side's 1 unit. The length we have is 1, 2, 3, 4 units. So opposite sides are equal, so I know that this side is 4 units. So in total, the perimeter is, I'm going to use friendly numbers here because I see 4 and 1 makes a 5, and that 4 and 1 is 5. So 5 plus 5 is 10 units for the perimeter here. Well, that's not a lot different than our first rectangle, which was 12 units. This is 10 units. So the perimeters are actually fairly close, even though you can see by just looking at them that, man, this one's actually twice as big. The blue is actually twice as big as the red. We're going to get into area a little bit coming up in the week. But for now, let's just focus on that perimeter being pretty close to the same, but not identical, which of course leads me to my question. Can we make different rectangles that have the same perimeter? Now here we have different rectangles that have different perimeters. But I'm going to ask you for today's warm-up, for your challenge today, to take a look, use the GeoBoard, and see if you can't make different rectangles that have the same perimeter, the same length of perimeter. So your question is, specifically, here it comes. Are you ready? Here's what I want you to do. Use the GeoBoard, make some rectangles, okay? And I want your rectangle to have a perimeter of 16 units. That's right, 16 units. 1, 6. 16 units for the perimeter. And I want you to make as many different, not congruent, as many different rectangles as you can with a perimeter of 16 units. That's your challenge. How many can you find? And how do you know that you found all the possible rectangles? Give it a go. I look forward to seeing your answer. Just take a screenshot and you can submit that to me so I can see your rectangles in your work. Okay? Talk to you next time.